Hello and welcome back to Homework 2.6. This regular octagon is to be used as a decorative window in the front of a house. There it is. I had to restart this video. I've been having the worst luck with videos today. The carpenters framed in an opening for it. How many degrees would they need to rotate it to make the window fit in the opening 8 different ways? Well, 360 is all the way around once, but you don't have to go all the way around. You can stop 1/8 of the way there. So we need 360 divided by 8. That is also the same as 360 times 1/8, right? 1/8 of the way, because you multiply across the top with fractions and get 360 and multiply across the bottom and get 8. Hey Google, what is 360 divided by 8? 45 degrees. I don't know. Do they want they want the whole list? 45 degrees 8 times. Or maybe 7 times, because it's already in one position. So 7 times would complete it, or whatever. You can do the multiples of 45 if you want. Find the distance between point A and B, then find the slope of that line that passes through them. All right, here's the thing. You can find the distance in the x direction, and find the distance in the y direction, and take this distance and square it, and take this distance and square it, and that'll be this distance squared, but then we have to square root it. So what would that look like, the x direction? Well, what's the difference between -3 and 5? Well, if you're starting at 5, differences find distances. So if let's say we weren't going to -3. Let's say we were going to 2. They're 3 apart. But we're going past that. We're going down to 0. That's 5 apart. But we're going past 0. Still, you're going to use the difference. What's 5 minus -3? 8. Because that's 5 plus 3. So that's the x direction. Let's try the y direction. We have to do the same order, so I actually have to go 1 this way. 1 minus 7 equals -6. And now we can square them and add them together. Oops. Square them, add them together. -6 squared, if you look at this is actually incorrect. This would be -36. That's not what we want. We want -6 squared. So it's 36. Ooh, it's 100. Then we take the square root of 100, which is 64 plus 36, and that equals 10. Now, why did I write 64 plus 36 instead of 100? Well, where did this 64 come from? It came from 8 squared. Where'd this come from? It came from 6 squared. And where'd this 8 come from? It came from 5 minus -3. I'm going to leave the squared there. Plus 1 minus 7 squared. And this is actually x2 minus x sub 1. Those are the 2 x coordinates from the very beginning. And these are the 2 y coordinates. I'm not going to go back up. You can actually put either x sub 2 or x sub 1 first, as long as you do the same thing for the y's. And then we square them, and we end up square rooting the whole thing, and this is actually the distance formula. So if we would have just done that from the beginning, it would have looked like this. Let's swap it. So let's actually put the -3's in first. -3 minus 5 squared plus 7 minus 1 squared, and square root it. That's the distance formula. This is -8 squared plus 6 squared. See, the signs switched, but it doesn't matter because we're squaring them anyway. Over here, remember we had +8 and -6. Whoops, I should have put a -6 there. But over here we have -8 and +6 because the first time in I put the 5 in first and the -3 in second. This time I put the -3 in first and the 5 in second. But as long as you're consistent, see, I also swapped the y's. I also put the 7 in first this time and the y and the 1 in second. As long as you're consistent, it'll all work out. Oops. So D equal, this was the distance formula. I should have had the little d equals this whole time. D equal 10. That's called distance formula. I think I might have just called it slope formula. Okay, what do we got today? What angles of rotational symmetry are there for a regular pentagon? Hexagon, you guys know this. Okay, if a regular pentagon has an angle of rotational symmetry that's 40 degrees, how many sides does the polygon have? Remember, this is this funny thing where regardless of whether you're given the number of sides or the degrees of rotation, you take 316 divided by that number, and it'll give you the answer both ways. And why is that? Because the number of sides times the degrees of rotation equals 360 always. So no matter which one of these you're looking for, if you know one of them but don't know the other, the algebra is divide both sides by the one you know. And so that's always the formula. Divide 360 by whichever one you have, and it'll give you the other one. Reflect. Ooh, challenging. Down 1, 1, 2, 3, 4, 5. Ooh, okay. So this one you might need to get a ruler out and actually measure it, because it's not 5 units away nicely. It's 4. So that means you're going to have to use the slope. This is -1/5. So the correct slope is 5. So we go up 1, 2, 3, 4, 5 over 1. So this is the line. However, where should P prime go? You're going to have to measure it. It looks like P prime is 14 millimeters away. Right in there. See, it's in the middle of a box. P, okay, you can, that's interesting. I don't even know how to do this. I mean, I guess you could get a patty paper. Oh yeah, you could use patty paper, but you could also translate this point C down here and point P down to its corresponding place that it would get translated, then rotate it using the origin, which is easier, and then transport it back. I wonder what that would be like. That'd be fun. Isosceles triangle. Explain why your construction works. CD is the base. And oh, they don't want equilateral. That's what the other two sides not congruent to CD means. So you gotta make the other two sides not equal to CD. Regular hexagon with CD as one of the sides. Construct this circumscribed circle around the hexagon. Note a circumscribed circle passes through all the vertices of the polygon. This is a good problem solving. Now you may not know how to do this. This is your chance to do problem solving. Problem solving is what happens when you don't know what to do. I haven't taught you how to make a hexagon without the circle to start with. But where do you, I don't know. You guys are smart. You've been playing around with these things. How could you find the center of the hexagon? How could you find the next couple of points of the hexagon? Construct a square. You have to go. You might want to just Google it or find it in the lessons and homeworks. We've done this before. Hint: you got to extend the line, and then make a circle that reaches out from D or C So then you can perpendicularly bisect right on D. What is the most famous of all geometric constructions? Hint, it's the Schoology thumbnail. Construct a parallelogram. You guys got this. Sequence of transformations. It's the famous sequence, point to point, side to side, and then reflect if necessary. Find the slope of the line that passes through the given points. Then find the distance between the points. Remember, distance, if this is x sub 1 and x sub 2, and this is y sub 1, y sub 2, then the distance formula is I'm just going to put x sub 1 first. And square that, and then add. This formula literally finds the a and the b lengths, then squares them, then adds them, then square roots it, so you find the distance. And hopefully, by now, we did so much Pythagoras, we'll be like, well, yeah, duh, I did that a bunch of times. And remember, slope formula is similar. Y's on top. Y minus y. X minus x. Watch your signs. Simplify. Traditionally, the y sub 2 and x sub 2 went in front. Y's on top. But it doesn't matter. It's just usually easier sometimes, depending on the numbers. I don't know. Google it. You guys are good learners. And that concludes the packet. We are ready for a test next Thursday. Have fun. I hope you enjoyed the quiz. Be nice to the sub. You guys always are. All right, have a nice weekend. Bye.